All right, so two complex numbers, adding and subtracting complex numbers. Traditionally, you should see parentheses around these. The only time you don't is when they put them inside of a fraction, because in the numerator, in the denominator, it is assumed to have parentheses there, so you don't have to put them in. But I hate to say it, we're not going to overthink this. You're going to treat these complex numbers just like combining like terms. We're going to think of that imaginary number as a variable. So what I would do is group the real numbers together. I'm adding them so we can add in any order. So 3 and the negative 2, group them together. Negative 4i and the plus 6i, group them together. 3 minus 2, 1. Negative 4i plus 6i, positive 2i. There's my answer. B, if you see a minus sign between your two parentheses of the complex numbers, distribute the minus sign. Negative 4 plus 3i minus 6 plus 7i. Now, if you don't want to regroup, I get it. Just draw arrows. Negative 4, negative 6, negative 10. 3i and 7i add up to be 10i. Now, something really cool I want to show you in the calculator is we want to change your calculator from the real mode to A plus BI mode. So let me grab my calculator here. We'll show you how we do that. Again, you hit the mode button. Go down there. Oh, my real is highlighted. Move your cursor to A. I said move your cursor to A plus BI. Have it flashing there. Hit enter. Notice it changes at the top. I am now in complex number mode. Second quit. Now here, you're going to like this. You can type in and check this. Left parentheses 3 minus 4. Okay, I is above the decimal point. You can barely see it on my screen, but it's there. Second decimal point plus parentheses negative 2 plus 6 second decimal point. Bam. It automatically adds complex numbers together. So I'm just going to move this off the screen because I blew up the decimal point. There's the I right there. There's my checking of my answers. So I'm still going to check your work by hand, but please type this in. The reason I say that is you can even go back. Let's back up the boat here. Whoops, right to here. This problem. Now that I have it in this A plus BI form, it can handle, wait a minute, there we go. It can handle this negative inside my square root. So I can go alpha y equals, get your fraction, negative 8. And I would just, we don't have the plus or minus, just do the plus because if the plus works, so does the minus. Second square root, negative 128. Jump down to the denominator, put a 4 there. Hit enter. There's my decimal answer. Type in your answer. Negative 2 plus 2 second I, that's the decimal point, second square root of 2. Exactly the same. Now you know this is right. And you can do that with any square root of a negative number. Take the original problem, type it in, take your answer, type it in. If the two decimals match, you know you're right. If they're not, go find a mistake. Fix it and get it right. So far, everything here in 6-1, you are going to be able to grade with your calculator now. All right, let's see. Let's get back. Well, that was after adding and subtracting. Oh, multiplication's next. Find each product. Multiply. Wait a minute. These are two binomials. You're just going to FOIL. All right, so 2 times 3, that's a 6. 2 times 4 is 8i. Negative 3i times 3 is minus 9i. Negative 3i times 4i is minus 12i squared. Now here's what's going to happen. Remember, I squared is defined to be a negative 1. Well, that negative 1 is going to change the minus 12 now to a plus 12. So anytime you get an I squared, you can scratch that and change the sign in front of that term. Combine like terms, 6 plus 12, that'll be 18. 8i minus 9i, that will be just I. There is my answer. B, if you want, it's a binomial being squared. When in doubt, write it out twice and FOIL it out. Do the same thing as we did here. Or you can use the formula pattern. x plus or minus y squared. Any binomial squared will be x squared. Whatever this sign is here, matches here, then x times y, and double it, because your two middle terms are always exactly the same, and y squared, always a plus. So if I use that here, I will have 4 squared plus 2 times 4 times 3i plus 3i, all that squared, which is 9i squared. That negative I squared, or excuse me, the I squared becomes a negative 1, which makes this a minus 9. Multiply everything out, subtract the 9 from the 16, 7 plus 24i. C, you should notice, hey, the only thing different here is the signs. You probably remember difference of perfect squares factor to 1 plus 1 minus. There's no middle term. So if I apply that rule here, this will be 6 squared minus 5i squared. Okay, well that's 36 minus 25i squared. But wait a minute. I squared is a negative 1. That's going to change the minus to a plus. And holy cow, we get a 61. We get a real number. There's no I here. So here's a case. We call this the product of complex conjugates. Complex numbers, the conjugate signs are different in the binomials. This will always be a squared plus b squared. That becomes a real number. So there's another little arrow in that diagram of your number sets. You can draw that over, and that goes into real numbers. Now, just want to point this out real quick. When we work with these complex numbers, sometimes in the directions, they are annoying. Okay, let me clear my page. This is a real pain. I apologize for the author. If the directions state, leave your answer in A plus BI form. If you get this answer 61, this is going to be completely annoying. I'm not kidding. You got to put in a plus 0i. You can put in 61, and if a window pops up that says, although your answer is correct, but it's not written in the right form, that's indicating you need that. Or if my answer was 7i, you need to put a 0 plus 7i. I know, I apologize. This is the author. That's the way he wants it done. I will not do that to you on the test. You don't have to write it always in A plus BI. I don't like that direction, so we're not going to do it. All right, again, calculator can grade it. Type it in just as you see it. Gives you the answers. So again, I am going to give you points for showing your work. If you go to the calculator just to get the answer, okay, you get 1 point. You don't get all these points. The 4 points for multiplying and doing the distributive property. The point for simplifying the I squared. Let's see, that's 5. The 2 points for combining, that's 7. Oh, and 1, that's an 8-point question right there. I know, I put a lot of points on your work. Show me your work. All right, division. Okay, so here, write your answer in A plus BI form. That might be in the directions. That's what I'm saying. I'm probably going to violate it here in the notes because I don't like it. But I'm just reminding you, watch your directions. Here, 3 plus 2i divided by 5 minus I. What we need is our complex conjugate rule. We need to turn the denominator into a real number. I is technically the square root of -1. You can't have square roots in the denominator, so we're going to rationalize the denominator. Put parentheses around the top, put them around the bottom. Multiply the top and the bottom by the conjugate of the denominator. Remember we did that when we were verifying Triggs expressions? 1 plus sine of theta. Then we multiplied it by 1 minus sine of theta and created a Pythagorean identity. Yep, still works right here. All right, so based on the rule, this is going to be 5 squared plus 1 squared on the bottom. Okay, that's 20. That'll be 26. Top, unfortunately, you got to FOIL it out. 3 times 5 is 15. I'll get a 3i plus a 10i, that's my plus 13i. 2i times i, that's my 2i squared, which I squared becomes negative 1, and it changes my sign to a negative 2. Scratch that out. Combine like terms, 15 minus 2, 13 plus 13i, all over 26. Okay, wait a minute. A plus bi form. You want to separate as two fractions. 13 over 26, 1/2. Plus 13i over 26, 1/2 times I. Now, if you want to put the I here, that's fine, as long as it's right next to the fraction bar. Safest thing to do is put it up in the numerator. B, this one might be entered in your notes wrong, because again, from Google Docs, I lost the fraction bar and it might say 3i. So please change it in your notes to 3 over I. So again, we want to rationalize this. If you just have an I term, and I don't care if it's 2i, 5i, negative 7i, that's all you have in the bottom is the I term. Just multiply top and bottom by I. 3i over I squared becomes negative 1. You just transfer the negative up to the top. Negative 3i is my answer. Again, calculator check. Alpha y equals. But when you type this in, you have to go to the math button and say return my answer as a fraction. Okay? The calculator is defaulted that when there's an I, it automatically puts it in decimal form. However, if you type in something like alpha y equals and you type 12 over 8, it will reduce it and leave it in fraction form for you because they're all real numbers right there. So when we have to work with i's, you will always want to attach this return my answer as a fraction for your division problems.